Okay, folks, sorry about that. What happened was this program I'm using only records 15 minutes, so I have to be a little more conscious of my time and stop at a sensible place. I just started using this and I'm not an expert yet. So this is section 4.1 or 4-1. This is the second video for that section, for section 4-1. And what I was talking about was I was trying to help you understand how to read a textbook and read technical matters. And this sentence right here is ambiguous. In general, a compound event consists of two or more outcomes or simple events. And I was trying to make a metaphor to something that we can all understand a little bit easier. So let me continue with that metaphor. If I were to say, my sister had a baby, it's a boy or a girl. When I say it's a boy or a girl, that's a dichotomy. Dichotomy, Dichotomy. It's one or the other. They're disjoint sets. It's one or the other, boy or a girl. And let's set aside political correctness here, okay? So that's pretty clear that the word or in that situation, a boy or a girl, is explaining the dichotomy. On the other hand, if I were to say my sister has a minor child or a child under the age of 18, that's not a dichotomy, right? When I say a minor child or a child under 18, the word or in that sentence is merely explaining what do I mean by a minor child. A minor child under the law is a child under the age of 18. So it's a minor child or a child under the age of 18. I'm using the word or to explain what do I mean by the word or the words minor child. So that's the metaphor I would make, and let's compare that to what we have going on right here. What we have going on right here is we have a compound event consists of two or more outcomes or simple events. Well, a simple event is exactly the same as an outcome. So it's not a dichotomy. It's not a situation where an outcome, you're either one or the other. You're an outcome or you're a simple event. By definition, an outcome up here, an outcome means a single trial of a probability experiment. So an outcome is a single trial. Down here, when we talk about an outcome, what we mean is an event with one outcome. So a simple event is exactly the same as a simple event is exactly the same as one outcome. All right. So I just wanted to point that out because I think sometimes people get confused. Just the language gets confusing unnecessarily. And I just try to point it out as we go along. I hope I didn't confuse you too badly there. Okay. So now what the author wants to do now is he wants to explain that there's three interpretations of probability. Okay, and here they are: classical, empirical, subjective. So let's talk about each one of those. But let me pause my recording for a second to make sure I'm doing this right. Give me one quick second here. Okay, I just checked to make sure everything was working properly. So the first thing we want to talk about is classical probability. And that's it's very straightforward. We're using the sample spaces which we defined previously, and we're trying to find what is typically referred to as a numerical probability that an event will happen. Now, so let's take apart this sentence here. Why are we saying numerical probability? It's because in some contexts, people will talk about probability and we're not using numbers. Like we might say something like, the chances of chances of getting a storm today is very high. Well, that's not a numerical probability. So classical probability is where you put numbers on it. It's a numerical probability. The chances of rolling a head is 1/2, or excuse me, of tossing a head is 1/2. If you toss a coin, you could have 1/2 chance of getting a head. Okay. Now, typically you don't actually need to perform the experiment to determine that probability. It's like flipping a coin. It's a head or it's a tail. I don't need to flip a coin to figure that out. I know it's going to be one or the other. Same thing with a deck of cards. If I pull a card out, I know the chances of getting a diamond is 1/4 of the 52. So it's pretty clear that I think, okay? So when we talk about something being an equally likely event, what we're saying is that the events have the same probability of occurring. So the deck is shuffled properly, it's a fair coin, things of that sort. Those are the concepts there. Now, the probability of any event is the number of outcomes in this set E. So this is where we need to be very clear on the language. An event is a set of outcomes, okay? So the set of outcomes, how many outcomes are in that set E? Okay, so this is an event, E, so it's a set of outcomes. How many of them are there? So we'll see an example here in just a second. And then down below here in the denominator, we have the total number of outcomes in the sample space. So this probability is denoted. The word denoted means it's labeled or it's exactly specified by this notation. So probability of E is the number of occasions or number of outcomes in that set E, and that's in the denominator is the number of outcomes in the sample space. Okay, so there's different ways of saying it. It's going to be typically, say for the classical probability, we're going to use a number. So we can say 1/2, we can say 0.5, we can say 50%. Everything means the same. It's just a different way of saying it. They're all equivalent. Okay, so here's a little explanation here about how, percent is not a probability strictly speaking, but oftentimes this is the way we express it. So it's close enough for government work. That's the way we're gonna express it. Okay. Now, we have these rounding rules. I'm going to let you read that for yourself, okay? These rounding rules drive me crazy, but you just got to know them. Okay, so drawing cards. Find the probability of getting a black 6 when one card is randomly selected. So randomly means that everybody has an equal chance of being drawn. So there's 52 cards. There's 2 black 6s, right? The event then are the 2 outcomes. You can have an outcome of a 6 that is a spade, or you can have an outcome that it's a 6 that's a club. So those are the 2 outcomes that you can have, as a result of one experiment. Those 2 outcomes make up the set of the event. So the event is a set of outcomes. So a black 6, the outcome, or the event, the event is getting a black 6. So if you wrote that out, it would be 6 of spades and 6 of clubs. There's 2 possible ways of getting that. There's 52 possible things of happening in the sample space. So boom, there's our formula. So it's 2 over 52. 2 over 52. If you reduce that, that's 1 over 26. If you fix that, you make that into a decimal, it's 0.038. Okay? Gender of children, same idea here. Probability that exactly 2 of the 3 children are boys. So you remember, you got boy, boy, boy. Well, that doesn't fit. That doesn't fit our requirement. We want exactly 2. So that doesn't fit. Here's one that fits. BB, boy, boy, girl, that fits. Boy, girl, boy, that fits, and so forth. Okay? So there's 3 ways of getting 2 boys and 1 girl. Okay, here they are. The probability of having exactly 2 is there's 3 ways of getting what you want. So the 3's on the numerator is on the top, and in the denominator is how many ways are there in the sample space. So you just kind of bounce back and forth. On the top you have the number of outcomes that meet the requirement, and on the bottom you have the number of outcomes that are in the sample space. Okay. So here's just some generic advice. When you read these blue tables here, or these blue boxes with definitions, 90% of the time it's not going to make any sense to you whatsoever. Do not be dismayed, okay? It will make sense when you get to the examples, but you got to go back and forth. You got to look at the example and look at how that relates to the blue box definition. If you don't do that, you're going to be kind of spinning your wheels here, okay? So All right, now we have a new topic. Now he's trying to parse the language himself here. He's trying to make it more clear. You got to understand that there's a big difference between the words and or. Those two words. If you the word and, let's take that as an example here. If you said I want to get, what's the probability of getting a queen and a heart okay, queen and a heart. You're looking for the requirements are it has to be a queen and it has to be a heart. It means kind of at the same time, or both of these requirements are met. The word or can have two meanings. For example, if you wanted to find the probability of getting a queen or a heart, well, a queen fits the requirement and the heart fits the requirement. So you could find one of the 4 queens, or you could find one of the 13 hearts. So the queen of hearts would be included in both of those cases. So there's 4 queens and there's 13 hearts. So 4 plus 13 is 17, but you got to take away one of them because you don't want the queen of hearts to be counted twice, right? So we'll see this a little more formally later on. So that's the 16 possibilities. Okay. How about if you were asked to find the probability of getting a queen or a king? Well, there's 4 queens, there's 4 kings. So there's 4 plus 4 equals 8. You don't have to subtract anything because these two sets are disjoint. It's either a queen or it's a king. You cannot have both. You cannot have a king and a queen. So both of these events, the queen or a king, they